Welcome everyone to the system design webinar. Um, yes, today is June 10th. Been planning for this for the last few weeks. My name is Dhirendra Sinha, as most of you have seen my email, my LinkedIn post, or you were referred by somebody in your friend circle. So welcome. A little bit about me. Some of you already know me. We have spoken. Some of you we haven't yet. So I did my engineering from India, from IIT Guwahati. Did my master's here at Texas A&M University. Um, sometime back. I don't want to age myself, but right there, the next bullet is my. You can see. I have 19 years of experience in software industry, different startups, two early stage startup, one late stage startup, and some small and big companies. Um, Currently, I'm at Google, but I worked at Oracle, I worked at Yahoo, worked at Cisco, and I have 9 years of software engineering management experience in various leadership roles. I have been very excited about coaching and mentoring engineers and managers. Been doing that for last 5 6 years. Also, I'm running this cohort-based trainings for the last 5 years in various topics I've discussed. I've done the coding interview preparation on data structure and algorithms. I've taken some courses on big data, the NoSQL databases, and recently I started the system design as well. I love teaching. I love learning myself. I'm a lifelong learner, so enjoy doing this. Cool. So, what's the agenda today? First important question is, why are you here? Then I'll talk about steps in a system design interview just to lay out the foundation. Why do we learn? Or not always necessarily for job interviews, but just to kind of lay some steps around how do you conduct yourself in a system design interview. Some basic steps. Okay, and then we'll take a look at a simple system we can build ground up, and then I'll talk about my course, which I take, which is starting on 17th, which is the next Friday. I'll commence the course. So a little detail about that. Okay, cool. So why are you here? Maybe you're looking for a job. Maybe you're looking to get promoted at your current job, or maybe you're looking to have a solid understanding of nuances of system design. um, or maybe your movie or dinner plan got cancelled and I have nothing to do. I hope that's not the case, but at the very least you'll have a good time with me. Okay, but talking about the first three um, reasons here, even if you're not looking for a job, what I have always seen is if you have a very good understanding of system design, how complex software systems are developed, designed, it gives you an edge at your current working company, at your current position, to call out some of the things, to suggest some of the things which may be hidden, which people may not be thinking about. And if you propose those changes, you ultimately get an edge, right? And that counts a lot, because a lot of times when you're at work at your current position, you sort of get settled into for lack of better terms, mediocrity, right? We kind of do our daily job, and we don't really look at from a fresh angle, fresh perspective. And sometimes learning about these things, you are able to look at your current systems and ask very good questions, right? You're able to come up with a solid design yourself, and that helps you to get an edge. It helps you to get promoted, right? So we'll talk about those things, right? Let's jump on to the steps in an interview, a system design interview. And these are the steps I put it together based on a lot of mock interviews I've done for my students, as well as at work. I've taken, I don't know how many, I don't even remember, 200 300 interviews in my career, but just a set of steps which will help you. So first of all, when the interviewer gives you a problem, right, a very simple, succinct framing of the problem, that's not it, right? You all know that. You want to clarify the problem and the requirements, and really drive to understand the nuances. You're the driver here, right? It's not that they will give you very well laid out statement problem statement, right? That may not be always very defined very clearly, and that's on purpose. You need to drive that. You need to clarify the question, the problem statement itself, which is your role, right? And then you think about a different scale, personas, access patterns, traffic patterns. What's the storage requirement? Clarify them. It's not like you make an assumption, and then you sort of you can clarify that this is what I'm thinking about, right? Does that make sense, right? You just do a checkpointing along the way. And if and be cautious here that if the interviewer points that let's design this particular thing, you don't want to sort of argue right there. You want to understand and clarify the problem, solve that, right? At the end of the day, sometimes I've seen in my experience, some people come in an interview and they design completely different thing, which was not even my question, right? So listen to the cues from the interviewer, right? And then clarify the problem, and then you can go out and design. Second step is, once you have understood the problem, once you have kind of limited the scope, thought about what is the exact problem you're going to solve, list the functional requirements. What is the exact functional requirement they want you to solve? Focus on that, and then write them down, right? Whatever the case may be, it may be there are different tools available, right? Whatever the shared document place, write it down. List the functional requirements. List the non-functional requirements, which are like availability, scale, consistency, durability, latency. What are the non-functional requirements, right? Which is sort of well understood. If it is a low scale, then a lot of things are very different. If it's a high scale, it's a very, very different design, right? So you want to make sure that you list them down and clarify and attest to it that this makes sense, right? Do the back of the envelope estimates, right? That is there, but also remember that it should be purposeful, right? It should not be like you start doing that and invest 5 to 7 to 10 minutes just doing the calculations, right? The big numbers, and you just doing the calculation by hand or on the if you are doing the remote interview, maybe you pull down your calculator and start doing those things. That is fine, but think about why are you doing those calculations. Stating that is very, very important, right? And once you have listed down, okay, so and so requests per second, or this is the storage, like this much petabyte you will be needing for storage. What does that mean? How would you use that input towards your design? If you cannot use that, then think about it. It was pretty much a waste of time, right? But you did a lot of calculation. You wasted 10 minutes. You could have really avoided that by stating few basic assumptions and go from there, and then start designing. So think about it. What's the purpose you're doing the calculation? People are not there to test your addition or multiplication or any such skill, right? So think about, be purposeful about. And then think about listing the APIs. So listing the APIs, which is the step number 5, is really a reflection of how well have you understood the step number 2, right? That's a little more clarifying or detailed set of APIs where you talk about, okay, fine, if this is the requirement, I would have a login API, I would have a create, whatever the case may be, right? A modify APIs, or this, like API, increment like API, whatever the APIs are, list them down. Okay? That gives you a clarity, first of all, that you've understood the requirements. Second thing, also, it gives you a segue into how would you really build the system up. Right? It gives you yourself a clarity and the interviewer also a clarity. Number 6 is you want to lay down a high level design with the block diagram. And this is not it. Sometimes people just lay out, okay, I have a client, I have a load balancer, I have this server, I have this database. That's a skeleton. You want to get, that's not your achievement, that's the baseline. So draw it out first of all, because on top of this you might build something up, which is your real interview question, right? So you don't want to take that as the sort of achievement that, yeah, done, this is my system design. That is the baseline, right? That's laying the foundation, and you should get that out of the way as soon as possible. So lay it out very clearly, right? And then on top of that, and then if you think about, okay, a particular system in the context of a particular system, if you identify some single point of failures, call them out, right? And those are your opportunity to open up a dialogue and start thinking about, am I really thinking in the right manner? What would be the bottleneck over here, right? And then you progress from there on. The other tip is try to write or draw while you speak. Sometimes what happens is you are speaking and you're making good points, but you are not writing it down or drawing it out in the diagram. And at the end of the day, what happens is maybe the interviewer is taking notes. You're at mercy of them taking notes, their due diligence in taking notes to capture what you have been thinking, right? You are your best advocate. So draw it out, write them down in some manner, because at the end of the day, your interviewer will take that snapshot, or whatever picture you have drawn, and the sentence you have written there, you'll take a picture of that and they'll submit it, right? So you want to be conscious that it's not only the verbal, good arguments or good trade-offs you have done, write them down, right? In that same page. I think that can help you a lot. Then go ahead, about thinking about the right database. There's always a database. You think about whether it is a SQL database or a MySQL database, or a NoSQL database, RDBMS versus NoSQL databases, right? What and what variety, which variety of NoSQL database would you use if at all you are using that? You have to be very conscious about it, right? Explain the reason why you chose one versus the other. It should not be right away. You are okay. I'm familiar with Cassandra. I'll just spit out Cassandra. That's not it, right? That doesn't make sense. Even if you're not familiar, first of all, once you cover when you are preparing for system design interview, you want to be familiar with all the different kind of databases. Choose appropriate database for the particular use case, right? You don't want to be randomly choosing because it's convenient, because it's simple, because you know it. Those are not the right reasons. The right reason is, why would you choose based on the access pattern, based on the read write pattern, based on the consistency pattern, the availability. Why would this database be most suitable, right? Go for that and give that argument. Um, then, of course, once you have laid these things out, you would go deeper into one area, because the interviewer is not looking for this high level thing and one database you have identified and laid out. That's not it, right? They probably will go further and ask you to focus on one particular corner or one particular specific area, where they will say, you know what, why don't we design this database tables, in this, why don't we design about notification service, something beyond what you have just laid out. This is just all groundwork. You're laying down the foundation, you're calling out the right things, but now on top of that, they may have a question which might require a discussion, a good trade-off to be made. And that is what you want to focus your most energy reserve for that, right? And after that, discuss and explain various trade-offs you have made. Even if the trade-offs you have made may not be completely correct, you should have a reasoning behind why did you choose that particular trade-off, right? That argument is very important, because for all you know, you might have actually made some wrong assumptions. That's fine, right? That can be corrected, but your reasoning should be solid. Your reasoning shows where you are. And sometimes what happens is, in an interview, you go there, you're always evaluated for level L and level L+1. There is always, like, you're never exactly fitting onto a particular level, right? The reason why you'll be graded for level L versus L+1 is, are those communication, are those trade-off statements, are those arguments or reasoning behind your choices, right? That is where you will be rated as L+1 versus L. So keep that in mind. Those have a lot of value. Okay. And last but not the least, manage your time very well, right? Practice it a number of times, different questions, and track your time. Like, how are you doing on time? Are you doing good on time? Are you sort of falling short? Where do you need to really buckle up and sort of make adjustments? Keep a watch. That always helps. Okay. Uh, so let's build a simple service, which is, let's say, photo sharing website you have, right? You want to build that up. So let's build that up quickly. Some probing questions before we deep dive into the system design and details there. We'll build it up gradually, right? And that will help you understand, why are we doing things, what problem are we solving. But think about these questions, right? Is it more of read heavy or write heavy website, right? Or service? What are we talking about here? Are there a lot of people who will be consuming these photos, or is it more of your personal thing where you do a lot of write but don't read a lot, right? Your personal, maybe Google Photos or any other photo service, you probably are not exposing their photos to a lot of people, right? They're not heavy reads, but it is more about heavy write whenever you. It's not even very heavy write, but still write heavy than read heavy, right? Versus like a Facebook or a Instagram, where it is like you write once, but that is viewed millions of times, right? Is availability or consistency more important? Which one is more important? And you'll see this trade-off time and again: availability versus consistency. What would you choose? There's a theorem called CAT theorem. I'm sure some of you may know about it, but basically that's covered in detail in my course as well. But that's a question you want to ask. How important is latency? Sometimes, latency is a factor which is a little related to availability, but slightly different. How important it is nowadays with the appetite people have is like they can figure out if some service is not working within, I don't know, 100 milliseconds. They can sense, and if a page doesn't render within a second or two, you have lost that customer. They lose the trust that maybe this website is not even prepped up. It's not even productionized properly, right? It's so slow. What is this? So this time and age, you want to make sure that your latencies are very, very low. It's very high priority, right? What scale are we talking about? That's another question you want to ask. Is it a high scale? It's a medium scale, or is it a very, very Google like scale? What are you talking about? That's very important because you design differently based on the different scales, right? How about reliability and data durability? Can you lose the data? Is it okay? Is it not? Sometimes it is okay, and you can make some trade-offs, but most of the time it is not okay to lose data. But we'll talk about how important it is, right? So let's go to, let me share the other tab. Okay, so let's say this is your first. Let me see if you guys, yeah, you guys are able to see this. So let me share this tab where we talk about some diagrams here, right? So let's say these are your clients, right? Different users having different, maybe some laptops, some mobile phones, and you have a simple setup, very simple setup, right? You have one server which serves as the app server, the database, and the photo store. Everything is over here. It has an IP address, and you have you connect over the internet. You have a DNS server, and this is how you have set up a basic business, the very first version, right? Which is register the app server with the DNS. So this DNS server has your app server and with its IP address, and the flow is the browser sends a request to the DNS server. From here, any of these browsers send a request, or app really, it resolves the IP address from this DNS server, and then the call goes to the server, which serves the request, right? You ask for a particular photo ID, and it replies with those bytes, and it basically renders in your browser as a photo. Simple, very simple. What are the problems here, right? If we are just building it up, right, how would you really scale it up and build it up to more complex scenarios? So this architecture, if you really see, is not fault tolerant, right? If any of this, the server crashes, you gone. There's no business, there's no website, right? So obviously it's not fault tolerant. It's not highly available too. Again, for the same reason, if the server crashes, there you go. You're not even available. Not scalable. That is your server. Even if you and we'll talk about what are the various methods of scaling, but definitely not scalable, not durable. If the service crashes and some of the writes are in the middle on the flight, they'll get lost, right? If you're uploading a photo and in middle of that, if the server crashes, you lose the data also. Several problems, right? What do? Let's go to phase two. So phase two, if you think about it, the way you can think about what can you do, you can separate, first of all, components of the collected component, which we said that app server will serve as everything. Let's first of all distribute that, right? You have an app server, database, and photo store, right? You separate them out first of all. And we'll talk about the reasons. And then second thing is you create more app servers just because there was one of the problem that it is not available, even if the server doesn't crash. But what if we are doing some upgrade? For that duration of time, it is unavailable, right? So best is to have multiple servers. So let's put in more servers, right? And again, DNS servers has both the app servers IP addresses. Let's say your DNS server basically can round robin between the two servers. So let's say we register both of them for your website, and let's see how does it behave. The reason why you split database and photo store, we could have said one database where there is a blob column where we can store photo store. That is there, but if you think about that, it's not the best way you want to store your photos in database, because whenever you load one row, you load the entire row itself, right? Along with the multiple columns, this heavy blob column will also get loaded up. Not the ideal scenario, because many a times you may not need for login or authentication or for any other metadata call, you don't need the photo to be loaded, right? So best is to separate based on the access pattern, right? So you can have a photo store. So that's the reason, right? Let's see the flow. Very similar again. Browser calls DNS server, gets the IP address of one of the app servers in round robin fashion, and the request goes. And based on what API it is, it serves from the database or the photo store. Very simple. Better than last time. What are the problems still? Again, any maintenance when done in one of the app servers is down, again we are back to the same problem, or one of them crashes, we are again back to the same problem. So we have some problems, we should have more. That is a hint for sure, right? So we can add more app servers, but DNS server is not very smart, it will do round robin only, right? So that is a problem. If this server is crashed, it'll still sort of or it's slow or overloaded, or we are doing any maintenance, still DNS server will go and route the request to that, right? So it's not very smart. So we need a better DNS server or some artifact here or some system here which can be a little more intelligent. Okay, so let's see what can we do next. So again, now let's be more sophisticated. So what have we added here? We put a load balancer between the internet, or the clients and the servers. Let's put a load balancer. And load balancer is a system where it's basically a component which is a little more smarter, right? It can have and depends upon what kind of load balancer it is. It can sense the load of all the different app servers and do a heart beating, figure out which one has more load, which one is down, which is doing very good, so on and so forth. It can have sophisticated algorithms like consistent hashing algorithm, so on and so forth. But it's a little more smart. So we have reduced that problem, right? Which just counting on DNS servers sort of routing algorithm, we have dedicated load balancers, a little more sophisticated software here, component here, right? So that's a good thing. Also, we have more app servers, so we are not back to two. We have multiple, three or more, so that we can rotate and sort of shard and load balance and a lot of things. We get when we have more app servers. Yeah, so that's what it is. Problems still, database and photo store both are still not highly available, fault tolerant, scalable, durable. None of those things are there because they are single systems, right? So all the other things are good, but these are the problems. How do we solve that, right? So let's think about how do we solve that now. Phase 4. So what do we do now? Let's think about scaling up the databases. So database was one single point of failure. So let's say we add more database machines, primary and secondary databases, right? This is primary, these are secondary, and replicate the writes from the primary to secondary, right? And we can think about how do we do that synchronously or asynchronously. Both have pros and cons, so we can talk about that. But really, what we have done is this is a primary, and the writes are replicated to the secondary. At any time, if primary is not available, again, there is a software in front of it, or sort of a load balancer or proxy, which can make some decisions based on if this database is for whatever reason it's down, it can quickly flip to the other one and make that as primary. And there are some pros and cons, but that can be done, right? So that and the other thing is, if the scale is very high, then these also serve as read replicas, right? If the read goes very high, so you could have those provisions also. But basically, what we have done is now reduce this single point of failure to not being that single point of failure point, right? Similarly, we can scale photo store, but we'll see in the next slide. Now, let's think about scaling up the databases. So database was one single point of failure. So we add, let's say we add more database machines, primary and secondary databases, right? This is primary, these are secondary. And we can think about how do we solve that now. Phase 5. So what do we do? Now, there is a trade-off, right? If you do write to all three replicas synchronously, meaning you will write to database primary and secondary one and secondary to all, and then you do an act back to the app server that goes back to the client saying that I've written your write, whatever it is a photo upload or modification or whatever it was, right? What you have done is you have increased the latency, right? But at the same time you have increased the consistency. So high latency is bad, but consistency is good, because at the read time you will read all the three replicas have same value, right? So you read consistent value. Versus if you want it to be write to be fast, then you can actually write to this primary and do an ACK and go back. That is pretty fast. Latency is very low, but at the same time the writes may not be written in time, and by that time if somebody reads the database from this replica, second replica, they might get some stale write. Let's say there is a feature here, right? So photo like was propagated here, was not propagated here, and in the meantime somebody reads it, they might see one less like, for that matter. Not a deal breaker in the like case, but in some other cases it might be deal breaker, right? So you need to design about that. So those are the trade-offs which is there. Understood. What are still the problems? Database is not highly scalable yet, right? In the sense like, okay, this is write and those are read replicas. We need to have a little more, let's say if it is write heavy, and we are always thinking about this is the primary, you want to write to this primary and then these are secondary. This is good for high reads, but high writes still this will be a bottleneck. If not, it's not failing, but it's a bottleneck, right? So we need to think about that. Photo store, yes, we talked about it. It's not highly available fault tolerant because it's just one store we thought about. So let's see what can we do. So this is the final final view. Maybe we could add some more things here, but let's take a look, right? So photos, we could introduce, again, I'm not going to go through this, but let's talk about what is in the picture, right? So first thing what we did was we made a bunch of databases here, right? And based on, there could be a component here, the proxy server or load balancer, which can shard and make all these people, all these databases act as primary for some database. So let's say user one it tries to upload one photo that goes through the load balancer. It is sharded based on whatever consistent hashing logic. It goes to, let's say, app server one. From app server one, it can go again because of this load balancer or proxy. I should have drawn that. That can go to any of these databases. Let's say it hashes to database 5. It actually goes to database 5, and then its copy is stored in database 4 and 3. Let's say it's a circle, right? Some such logic you can put in. Let's say these two are the replicas for this guy, right? And this is the primary. For user 2, maybe it will hash to app server 3, and that then gets to DB2, for example. So you have really, what you have done is high amount of write traffic you have sharded to multiple databases. So you have now reduced a single point of failure. You have made the database as highly scalable. You can add one more machine and things will work, right? So that's good on that part. Again, you can put some cache, so you don't have to all the time go to the databases. You can put some cache, and there are several caching strategies. Again, that's in my course where you look at several caching strategies. What's the best strategy for particular access pattern? We can take a look, right? But caching helps. You don't have to always pressurize the database and get the data. You can always cache some of the data. What is CDN? CDN is useful. It's sort of a cache for static resources. It's called content delivery network. For example, if there is a static thing like a movie or a video or a photo, those resources can be cached all across the world, right? Let's say if your photo service goes global, then somebody living in India or Europe or Australia, they need not come all the way to your primary set of servers or databases, which let's say primarily is in US, right? You don't have to for the static resources, which are heavy many a times, right? You can actually have a local server right there sitting in India or Australia where you are, and it contacts that local CDN, gets the static resources, and for all other dynamic resources, it actually goes and fetches from all these, aggregates all the data and gets back to you, right? So those are the things you could do. Maybe the other last thing is put a messaging. If you think there are some asynchronous processing you could do, or there are some processing you could delegate and do it asynchronously later on. You could always have, at different places, you could have some messaging service or a Kafka PubSub kind of system where you just deposit the message that do this, and then acknowledge back to the client that you're taking care of, right? And then there is a offline consumer which runs through that multiple set of consumers, and they process their data actually and ingest in the system, the real system, right? Which many a times may be okay, but not always, right? You have to think about what's a read write access pattern, what's the use case. Based on that, you can put in there, because that also acts as a shock absorber. If there is a huge amount of data coming in, you can write to this queue and sort of collect the data in the queue, and then later slowly drain the queue, right? That also is a facility which you could use the Kafka queue as, but also basically to decouple different systems, right? To be able to really do a fast write. If it's a very heavy write, it might make sense to actually just write to the Kafka queue and then return back as an ACK, right? So this is a basic system which we have built from scratch, from nothing to a little high scale. And there are many more nuances which you need to think about, but this is a basic walkthrough of a system which we have built from scratch. Cool.